Welcome back to my channel. I wanted to do a follow-up video to a video I recorded last week, which was about the COVID-19, how the numbers are growing, how long can we expect to be quarantined, and the math behind the coronavirus epidemic. So I wanted to do a follow-up because I made some projections about where we will be at the end of March, and so I wanted to do a comparison of what I projected and where we actually were with the numbers. And so what I have on my board here is I have the actual projected numbers. I projected the number of cases that we would have in the U.S. and I also projected the number of deaths that we would have based on a simple exponential model. Now, if you haven't watched that video, go back and watch it. You might want to watch it before you watch this one. The link is in the comments below, so you can just click on that link and it'll take you to that video. I'll walk you through the steps on how I made a simple exponential model using the TI-83 calculator. So I projected that we would have 154,687 cases on March the 31st in the U.S. of those being tested positive for COVID-19. We actually had 188,530, which is way more than what I projected. The actual difference is negative 33,843. That's negative because my number was less than the actual number that we had. So what this means is that the numbers were actually growing faster than what our model suggested. Now, that totally makes sense because they were ramping up testing. So the more we test, the more the numbers are going to grow. And so as we continue to ramp up testing, those numbers will continue to grow really fast. I also predicted that we would have 3,603 deaths on March 31st. Not on that day we would have that many deaths, but that's how many people would have died from COVID-19 from the beginning, from the first case being here until March 31st. We actually had 4,053 deaths, which is a lot of deaths, y'all. But that was a difference of 450. My number that I projected was down 450. And that's not a bad model. That's really not that bad of a difference. So what this tells me is that my model for the number of deaths was more accurate than my model for the number of cases. And it makes sense when I was watching the news conference the other day, and Dr. Chris Murray, who is the one who's been creating the models for the White House task force to use, he was on CNN and he was saying that he uses the number of deaths as his independent variable for his models because they're more accurate than the number of cases. So when you do a number of cases, you have to consider all the different issues that are taking place with testing. Not everybody's getting tested. Some cities are testing more than others, and so forth. So I also was happy that they showed us a model on the White House news conference the other day, and I want to use a particular date on that or from a model that they showed on that White House conference to make a new model and do a new prediction. So let's look at the model that they showed us at the White House conference the other day. So I was so excited the other day when the White House finally posted a model. They've been referring to these models over and over, but they hadn't been showing them. So they showed a couple of models, and this is one of them I took a picture of. This is the model of the number of deaths per day. And as you can see along the x-axis here, they have the dates. And then along the y-axis, they have the number of deaths per day. Now, they are expecting the number of deaths per day to peak around mid-April. If you can see, there's the peak right there. If you go down, it's mid-April. Now, this isn't when people will stop dying. This is just when we'll have our worst day. So they're expecting our worst day to be around mid-April. But as you can see, people will still continue to die all the way up until the summertime. They're expecting all the way to July. Again, this is just a model. This is what they expect. Nobody really knows what's going to happen but God. But I want to use this model to take this mid-April date to make another prediction about where we will be with the total number of deaths by mid-April. So I showed you how I was housing my data before. It's just in a simple Excel spreadsheet where day 1 represents February 15th. I'm starting at February 15th because the website I'm using is called Worldometer. That's where they first started tracking their cases on February 15th. And these numbers, I've been checking Johns Hopkins University as well. They're pretty close and accurate to what Johns Hopkins University has been reporting. But I have the number of deaths all the way up until April 2nd, which was yesterday. Yesterday we had 6,070 deaths. Now if you plot those, scatter plot, you see that the graph follows an exponential function. And So what I want to do is I want to take and make a basic exponential model to represent the number of deaths. So again, I took the data that I just showed you in the Excel spreadsheet and I created a simple model using the TI-83. Again, there is technology out there, lots of technology that'll give you more sophisticated models than what I'm about to show you. But this is just something we use in our math classes on a daily basis. So I wanted to do something that's relatable to the students. So I got this model right here, y equal 0.0706 times 1.2681 raised to the x power, where y represents the number of deaths and x represents the number of days since February 15th. And so what I want to do is I want to use that date that I showed you at the peak from the model that the White House Task Force has been using. The experts are expecting us to hit our peak around mid-April. So I'm using April 15th as the date I want to make projections for. April 15th is the 61st day. So if you go back and look at my spreadsheet where I showed you one was February 15th, if you keep going all the way to April 15th, you'll have number of days being 61. So what I want to do is I want to replace X with 61 and I want to calculate how many deaths I'm expected to have. Again, I'm using a basic TI-83 calculator. If you plug in 61, then you get y is equal to 138,410. So that means by April 15th, we can expect to have around 138,000 deaths in the U.S. from COVID-19. Now, that is a lot of deaths. And I'm not trying to make this video to scare anybody, but what I am trying to do is show you all how they're using models to make predictions and to make serious decisions, such as stay-at-home orders, such as distancing yourself, only going out if you're an essential worker. If you have to go to the grocery store, be 6 feet apart from each other. Now, these predictions here are based on if we're doing nothing, right? This doesn't take into account the mitigation factors. But the White House predictions of 100 to 200,000 deaths through all of this is based on everybody doing mitigation factors. And at the time of this video, this is April 3rd, not all states are doing stay-at-home orders. So here's my question to you guys. Do you think we should be doing stay-at-home orders? Do you think every state in the United States should be under a stay-at-home order? Put your thoughts in the comment below because I really want to know. I really want to know what people are thinking. I know what my thoughts are. I think we should all be on the same page. But I want to see what everybody's thinking and the justification behind it. So again, these numbers is if we don't do anything, mitigation factors could help us slow this growth. So y'all take care of yourselves. Please stay at home if you can. If you have to go out, now they're saying you should wear a mask. Everybody should wear a mask when they go out. Not the N95 mask that the healthcare workers need, but just something to protect yourself from giving the virus to others if you have it, because you can be asymptomatic and carry the virus. Now, I wanted to show you the numbers, but I also wanted to do a call to action to all of my teachers out there, my algebra teachers. So whether you're a high school algebra teacher or you're a college professor. So during this time, we're thankful and blessed to still be able to have a job, to still be able to work. We're just working from home under different circumstances. And one of the things, a lot of conversation that has been going on in the community where I am is, how do you still hold your students accountable? How do you assess them? How can they take tests at home? And so what I want to do is I want to challenge you to rethink the way that you're assessing your students. And I want to give you an idea for a project. Take one of those tests or two of those tests that you have planned for your class and replace it with the project. Have your students find a graph related to COVID-19 and have them interpret the graph. So they can use a model similar to the model that I showed you earlier. I showed you two models. I showed you my exponential model, but they can go online and find a model that somebody has created related to COVID-19, and you can have them do a video description of it, or you can have them do a written description. That's one idea of a project. Another idea for a project is, there's been a conversation about herd immunity. Herd immunity is doing nothing and just letting everybody develop immunity to the virus. The UK was going to try this concept, but they changed their mind really quickly. And President Trump mentioned in the White House conference the other day that he had people telling him to not do nothing and let people develop basically herd immunity. I did a little research and I found out that 70% of the population would have to test positive or develop the COVID-19 in order for the herd immunity to be in effect. So what you could do is you could have your students find the U.S. population, calculate what is 70% of the U.S. population, have them create a model for the number of cases of COVID-19 in the U.S., and then have them calculate how long would it take for the U.S. citizens to develop herd immunity. That will result in them solving an exponential equation, and so that takes some deep understanding of exponential functions, exponential modeling, and exponential equations. How would you solve that equation? That's another example of a project. So I want to challenge you all to rethink the way that we're assessing our students during this time. I also want you to keep in mind that these are very unprecedented times. So think about what your students are going through. We're going to have students that are losing loved ones, that are losing jobs, that are faced with depression from being at home alone. They're going to be going through so many things that we can't even think of. So keep that in mind as you're trying to teach your students and hold them accountable at the same time. So please share this video. I don't know a lot. I know a little bit. So I'm just sharing with you what I know. And based on the models a simple model that I've created, this is where we can expect to be by mid-April. And as you saw on that model, that's just the peak. We're not going to stop losing lives mid-April. Lives are still going to be lost after April, all the way up until about June. So this is serious, y'all. Please take it serious. Please think about not only yourself and your family, but think about others. Lend a helping hand during this time. And we will get through this. We will get through this together. I will be praying for you guys, and I will be praying for all that I know in this whole country, and not just this country, but the whole world, because the whole world is being affected by COVID-19. So thanks for tuning in. If you have any comments, anything you want to add to this conversation, include them in the comments below. If you like this video, hit the like button, and if you want to share it with someone, please feel free to share it as well. Thanks again for tuning in. I'll see you in the next video.